Okay, now that we did motion and understanding a really good chart, we're going to go in and look at motion in one direction, but this time vertically, with the main difference with vertical motion being the fact that gravity is playing a role. And so 2.3 is vertical motion. So everything that goes straight up and straight down is under the influence of gravity. So that means our acceleration is going to matter. And for gravity on Earth, in standard units, the acceleration is also labeled g. And on Earth, g is equal to 9.8 meters per second per second. So a change of 9.8 meters per second for each second. And it's downward, so we'll have that negative. And it's also written as, putting the seconds together, minus 9.8 meters per second squared. Now this is a number that you would use for mainly lab, but you can see that it's very close to 10. So when you're doing problems in physics, it's helpful to make it 10 meters, minus 10 meters per second squared for our g value. And some other values on in other places other than the surface of Earth are, we'll write a little table of that. So we could have Earth, we know is about, we'll just use the positive value here, 9.8 meters per second squared, and that's also called 1g, for 1g is in g is around 10 or 9.8. And so you often hear like you feel an acceleration of 2 g's on that roller coaster or something like that. On the moon, well, the moon is smaller, so its gravity is, or it has less mass, so it's only 1.7 meters per second squared, or 0.17 g's. And Mars, also smaller than Earth, 3.7 meters per second squared, or 0.38 g's. And Jupiter, much more mass than Earth. It has a 24.8 meters per second squared. So that means on Jupiter, you drop something off of a building. If you could get a building to Jupiter, it would, and it's falling, it would increase its speed 24.8 meters per second every second as it falls. So that's about 25. So you can imagine as it falls, after the first second, it would be going 25 meters per second. After the next second, it would be going 50 meters per second, etc. Where on Earth, with a 10 meter per second for every second, when you drop it, after the first second, it would be going 10 meters per second, the next second, 20 meters per second, then the third second, at the end of it, 30 meters per second, etc. Okay? So, and that comes out to 2.54 Gs. Pluto, our old planet, no longer classified as that, is only 0.49 meters per second squared, smaller than in mass than the moon, and is 0.05 Gs. The sun, with all its mass, is 270 meters per second squared, or about 28 Gs. So just some values to consider, and there's more listed on your reference table. Okay, so we use the same really good chart for problems, It's just that now we are doing problems with with the acceleration being minus 10 due to gravity.